we're not that serious generally, but it's great. It's 8:55. It's 5 minutes to 9, and we are starting. So 5 minutes before than other times. Thanks for being this punctual, and a big applause to you. There are some seats here in the front for the people that are coming now. If you come late, you need to stay in the front. Okay, so welcome everyone, and this time it's Speck&Tech number 47, and a big applause to all of us. It's nice to see that in the room there are some speakers, some people that were here in 2016, some people that were here in 2018, and some people that are here for the first time. Is it your first time? Can you raise your hand if it is your first time at Speck&Tech? Okay, some 20 people. Can you raise it again? Raise it again. Yeah, some 20 people. Interesting. Okay, so more people coming. People coming now, you can sit here in the front, there are a few seats. Okay, Speck&Tech number 47, this event is named Free Software, and it's good to see so many of you here. Tonight we'll be talking about free software and open source with two speakers. Here you see them. The first one is Francesco CORCOGLIONITI, a big applause for him. And the second one, here is coming directly from Berlin. Yeah? Coming directly from Berlin, flying here, Tobias. Big applause. Okay, true. Not flying. Coming by train from Berlin. Okay. Before starting, since there are some 20 people here, I saw that it's the first time for them at Speck&Tech. This is how we started. This was an empty room full of chairs. Nobody showing up. No, it's not true. Some people came up and we started Speck&Tech. It was 2016, and this is how it came. And we're close, getting close to there. Like we are almost 100 people tonight, maybe over. Maybe more than that. We've done a lot of things with Speck&Tech over the years. This was 2018 where we organized an event in the airport of Trento, but we went to Muse, we went to Piazza Duomo, we went to Munich, Monaco di Baviera. And in general, we organize an event where we talk about tech and then we eat speck and we drink beer, which is not bad, I have to say. As you can imagine, over the years, there was COVID as well. Luckily, right now, it seems a long time ago. During COVID, it also became a podcast. So if you are into podcasting, there are some nice episodes. You can find them on our website as well. Of course, Speck&Tech had a hard time due to COVID. But we came back stronger with a brand new team, more people helping out and giving their hands. And right now, there's a great organization managing the event, and I think these people deserve a great applause. So tonight is our 47th event, as I told you, and it's actually an event that we organize in partnership with NOI Techpark, which is the innovation hub of Bolzano, as we can say. And I would invite on stage Patrick Onevine here. So a big applause for him as well. We give you the mic.
Uno, due, tre, perfetto. Okay, hi all. So I came Bolzano, and doing here in Trento is quite a similar thing. We are trying to create a community of developers. In Bolzano, I don't know if it is in Trento as well, we have the issue that developers are living which is good in valleys. They are in the nature, but there are difficulties to meet other developers, and sometimes they feel lonely. So what we are trying to do is to organize events where developers can meet, can share their experience with technology, can create new teams for future projects, for research and development projects, and also for startups. So we are a technology park in Bolzano, and we are committed to help developers creating startups, to work together with university and other research centers to find fundings for their projects and so on. What we are doing for this in these days is to organize a conference which is called South Tyrol Free Software Conference, which we are organizing since 2001. So it's quite some years we are doing it. We started as students, very little gathering, and these days we are organizing a huge event. We are expecting hundreds and hundreds of participants from all over the world, and we decided to do it like a festival. And if you look here, oh, there should be a pointer as well. We have one side event, we have multiple side events, and where's the Speck&Tech? It's not here? It's the following one. Ah, okay, we are missing it here. There are a lot of side events, and one is a Speck&Tech. The events are kind like this. There are humans, there are robots, there are a lot of freaky stuff, and we can do this thanks to our industry sponsors. We have this year, we are very proud to have Eclipse Foundation as sponsor, then other companies. Maybe you know Collabora Online if you use LibreOffice Online, and other local startups and companies, but I don't want to bore you with this. And how is it organized? Here we have Speck&Tech Live as a pre-event. So we are now this week having a lot of events to gather together the experts. This is, for example, a picture of the speakers dinner. We have around 100 speakers who will speak at the SFScon, and they are doing their event, side event. And then we have 2 days of a lot of fun, talks, parallel talks, and also a hackathon. So if you are available to stay at the NOI Techpark for 24 hours without any sleep the whole night, so you can use our facility and hack for 24 hours. We have supporting companies which are providing you prizes. So the prizes, so we have in total, I think, 6 challenges from different sponsors. Every challenge will be disclosed on Friday, midday, and you will have 24 hours to provide a working prototype as a team. You can team up with others if you want. If you want to play solo, it's okay, but you can team up until 4 people, and the prizes are around, 1,000 euros, usually vouchers or other things. So you have 6 chances, 6 availabilities. We can offer everything for free thanks to the sponsors I showed you at the beginning and I didn't mention properly, but we are happy they are supporting us. And so you can participate if you have time this Friday and Saturday. Come to the NOI Techpark in Bolzano and let's have some fun as software developers. That's all. Thank you to Francesco and to all the speckers who usually win the hackathon prizes actually. And I'm very proud about Tobias, because Tobias also started as a hackathon participant, or we know each other, because when he went to high school, if I remember well, or it was the first university year, he was one of the hackathon participants, and now he is in Berlin, and I'm looking forward to your talk, Tobias. Thank you very much.
Thanks, Patrick. He was saying it right. We speakers usually win the hackathon in Bolzano. I think since 2016 till 2019, we almost won every edition. And then COVID came and we said, okay, it's too far. We don't go anymore. But it's really cool. Great prices, amazing food, terrific venue. If you want to go to Bolzano, really recommended. Before moving on, let me just quickly hand it over to Giulia because she has something to say.
Okay, obviously we know that you are here for the amazing talks we are hearing today, but also for the amazing networking after the event. And basically, yeah, we have some our affectionate representatives showing that networkings also happen and it's amazing. They totally recommend it. And obviously, we don't charge you for anything. It's totally free, but you can support us by donating and donating in with our stickers. They are really beautiful. You can place them on your laptop and be super cool at university. But also you can slay with the new t-shirts we have. They are red. Our model is showing you. They are really, really good t-shirts. And you can donate, get the t-shirts, stickers, whatever with cash, Satispay, whatever, it's welcome, kidneys too. And you can do it to the table there. We will wait for you, obviously. And nothing. Obviously, we have an amazing website. Here you can find tons of information of our next events, all the news upcoming, obviously getting the tickets for next event. And you can support us, write if you have any ideas. If you want to become a speaker and come here and tell everyone about your passion, a topic you are really interested into, you can do it, just contact us. And obviously on our website you can find the previous talk, topics, slides, and all the materials for university. They are really, really useful if you want to do a project or whatever. And more important, if you're looking for a job or something, we have a really good opportunities here from our sponsors, and you can just apply for them. And nothing. So to stay tuned for all the upcoming events, news, and similar, because there are so many, but we don't spoiler them. You can follow us on Telegram, Facebook, Instagram, Twitter, LinkedIn, whatever you want. And after every event, we will really enjoy if you can leave us some feedbacks to make Speck&Tech great every time a little more. And
concrete feedback, severe feedback.
Yeah.
If you think Giulia and I speak too much, say it. It's true.
Exactly.
It's true.
Exactly. And if you want to make questions or share your opinions or similar of the what speakers will tell you, you can do it by sharing your question and similar on slide.do st47. And then you can not only write your question, but you can also upvote the other question, and we will make them to the speakers after they talk. Okay, so I think that I talked too much.
Cool.
And we can start.
First speaker on stage, Francesco. The stage is yours.
All right. So, thank you everybody for being here and for attending my talk. I'm Francesco. I work in UniBZ. I'm a postdoc. And I'm here talking about some of the topics, some of the activities I work on there, about virtual knowledge graphs, and some of their extensions to web APIs. So this is going to be a technical talk somehow. I mean, we are going to look into some topics that are related to the semantic web world. So I'm talking about a bit ontologies, RDF graphs, queries. If any of you have some background on that, could you raise your hand so I can understand a bit? Okay, semantic web ontologies, RDF. Okay, not many of you. Okay, I will try to not put too much details during the talk. Okay, so let's start. As I was saying, I would provide an introduction of knowledge graphs, virtual knowledge graphs. It's the way we deal with them here. I will talk about a free software system on top, which is developed in my institution and by also a startup that we have. It's available, you can use it, it's quite mature, and there is quite a nice community about it. I will talk to you about some extension for using this tool, in particular with web APIs, and then some conclusions. Now, a bit of context. Don't have to tell you we are in the big data area. So there are the big four, the four V of big data: volume, variety, velocity, veracity. What is interesting is that variety, so the differences between the different sources, schemas, data, accounts for, it's perceived as one of the most important factors in data integration processes. So why? Why there are different forms of heterogeneity that hamper the development of activities. Here I listed the four of them. So the data model can be different, so you can work in some project where you have to deal with the relational data, graph data, CSV, JSON, whatever. The systems can be different, and even if they have the same model, they can have different dialect of this model. Think about all the relational databases, Postgres, MySQL, whatever, that have different dialects. The schema, so even if me and you, we both use Postgres, we may model the same domain with a different schema, so we have tables that do not match. And even if we use the same schema, the data may be different, because I may have a table of companies, and I write IBM as the primary key, and you write international business machines, and so the two things will not match. So these are things that have to be addressed when you try to integrate data from different sources. And that's a difficult task. Now, here are two examples from use cases my research group worked on in the past. So on one side, we have a use case from a European project and Statoil, that is now Equinor, which is a company that works in the business of oil extraction. So what happens is that the geologist, the worker of this company, they have some query they want to answer on the database of the company. It's a database about oil extraction-related data. So here is an example of query, but what is important is that the query in natural language is simple. The query, once expressed in SQL, it requires accessing 9 tables that have to be joined together. The biggest one of them has 38 columns, was named as cryptic. So the experts are not able to write this query at all. On the other side, you have another example. It's another use case, which is about studying stars and collecting properties of stars. So you have a query, give me all the white stars that are in my data source. Okay, problem, in the data source, there is no concept for white star. You have some parameters of the star, like frequency bands, whatever. So you have to express your idea of what a white star here is by writing this complex expression, but your query becomes completely unreadable. So the problem is all these difficulties in writing queries that have to address possibly different data sources that are complex and are hard to understand, they complicate the data integration process. So in the solution that was developed for one of the solutions that was developed for tackling these issues is the one of virtual knowledge graphs. And it builds on 3 key ideas. So the first of all is, if the schema of the source is not good, let's focus on a global schema that is defined using the terms of the domain, and then we map the sources on this global schema. So we provide the user a schema that is more simple, it uses the terms of his domain, he can query this schema, and then we have all the machinery that answers this query by going to the sources, so using mappings. The second point is, okay, which data model? Let's use the one of knowledge graph, because it's a flexible data model. And also it allows to give it a formal semantics through ontology. Ontology is a way to define the schema of your data. Let's put it this way, okay, to simplify things. And as I was saying, virtualization. So we do not take all the data, put it together in a single knowledge graph, but we keep the data in the sources. We don't have to we don't want to move, let's say, 10 terabytes of data all together. What we want to do is to give the abstraction to the user of a single knowledge graph that is not materialized, is virtual. So when the user queries this knowledge graph that is virtual, his queries actually split in sub-queries, so-called native queries that go to the individual sources. Okay, this is the overall picture. It goes under the name of virtual knowledge graph, but since we also use ontology to access data, there is also ontology-based data access. So, okay, just before moving forward, just a bit an introduction of the core components of this virtual knowledge graph technology. So here we have, we have an overall view. You see, we have the data sources. We have the ontology that defines our domain. I have the class of, let's say, the actor, the movie, the relation of playing of an actor in a movie. And then I have mappings that tell me how to map the content of the data sources to instances of these classes and properties. The user asks a query on this virtual knowledge graph using the terms of the ontology, and we answer the query using the mappings and going to the sources. So more or less is what I wrote here by listing the key ingredients. Okay, let's go more into the details to go on this overview of virtual knowledge graphs. So the framework. So as I said, we have different ingredients. And the first problem to have to be addressed from a design perspective is to decide which languages, which formalism to use for each one of them. And here we have to balance two things. We have to balance expressive power. So we want to write queries that are expressive. The ontology should be expressive, allowing us to express semantic relations like a movie is a kind of play, a movie actor is a kind of actor, so subclass of. So we want this kind of expressiveness, but with expressiveness, it comes also computational complexity. So we want query answering to be efficient. So we have to find a good balance, which is done by restricting expressiveness, of course. So in order to do that, with time, there have been a bunch of standardized languages that have been put forward by the W3C consortium. So we have RDF, which is a data model for expressing graphs, RDF graphs, and this is the model of your data as a graph. Then we have a language, OWL, in its variant OWL2QL, for expressing the ontology. We have a formatter to RML for mappings, and we have a language, Sparkle, for query. Sparkle is quite similar to SQL in a sense, at least superficially, the form you can recognize similar keywords, but then you are operating on a graph and not on a relational model, although the two are not so different. I mean, a graph is a set of triples. Now, let's go into these different ingredients. So, RDF. Here is an RDF graph, a spaghetti thing, where you have nodes, and you have directed edges between the nodes. So this is your data as a graph. And the nodes of this graph can be of two types. Internationalized resource identifiers, IRIs. Formerly, they were known as URIs. And a URL, that one you type in the browser, is a form of URI. Here is an example. So, but you can also write in an abbreviated form. And the literals, so data values, like the one we have in these boxes. And you can use these nodes along with the relations. And when you have a relation between a subject node, like this one, A1 is an identifier of some entity. A property, RDF type, it denotes the type of some entity. Actor, which is the identifier of a class in the ontology. Here you are denoting, let's say, an edge in this graph with a specific semantic that is given by the ontology. Here I'm saying I have an entity with an identifier A1 whose type is actor. Here I'm saying the same entity plays in this other entity. With this other entity now I didn't put it here, but it's a movie. a movie that was release date is this one. And I can go on, I can model all the data I want, because this is a very, very simple data model you can expect verbose way. Okay. Once we have this data model, we would like to have a way to define, formalize the scheme of this model, and an ontology does that to that respect. So OUL2QL is an ontological language, so a language that you can use to express an ontology, is part of OUL2. And usually you can depict it as a kind of graph when you want to convey the meaning of an ontology. You can use a class diagram, because there is a close correspondence. So you can look at each class as a class, and then you have the properties, and then you have the relation that we have here of generalization is a subclass relation. So you can interpret, you can read a class diagram as an ontology of this language. Of course, some things that you can express in a class diagram, you cannot not in an ontology. So there are some differences, but it's a good representation when you want to convey an ontology. Although, I have to say, an ontology is a logical theory. So every time you write an assertion in your ontology, like saying that a movie actor is a subclass of actor, what you are doing, you are creating, you are declaring an axiom in a particular fragment type of logic that is description logics, and more specifically for our case of virtual knowledge graph is the L-light, which is a particularly restricted form of restriction logic, description logic. So you see here, I want to model my domain. I want to say that a movie actor is a subclass of actor. I can use this assertion using the OWL language. So this is the RDF encoding of OWL. So I write this in my ontology file. It's a file in the editor. I write this. What I'm doing, I'm creating this logical statement. And then I can do other kind of assertions. I can say that two classes are disjoint. So if you are an actor, you are not a movie. The two things cannot coexist. I can say the domain of a property. So the subject of acts in must be a movie actor. The object, so what is being acted in, is a movie. And so on and so forth. There are a bunch of kind of assertions that you can express, and with this you are defining, formalizing your domain. And since we have a logical underpinning of this language, you can do reasoning let's say, in a sound and formal way on the ontology. Now, that was ingredient 2, the RDF graph, the ontology. If it works. Maybe I run out of. Okay, don't problem. Also, tell me the time because I'm not looking at it. Okay, it's working. Thank you. So, as I said, we have the data sources. Think about a database. We have the ontology, the scheme of the knowledge graph I want to map my data. We need the mapping that tells us how to map the content of the database to the ontology. Here is an example. So now I skip this formal stuff. I just give you an example here. So a mapping is an assertion where you have a source, is an SQL query. You can see it here. Give me the attribute mcode, the attribute mtitle from a movie table, with some conditions. So the type must be M, because maybe in this table we have other stuff. And once I get these two attributes, I can construct these triples. I construct the triple mcode. This is an abbreviated way of denoting a URI, RDF type moving. Mcode here as title, mtitle. So actually these are two assertions because each assertion defines a triple. I can do the same for the acts in. So the point is, once I have the mapping, I have the ontology, I have also the database, so my table movie, my table actor. I apply the mappings on the database. I also use the ontology to derive all the possible logical consequences of what I get from the mapping. And here is the list of triples of the knowledge graph that I can extract from here. So I have a movie, M511, which is the matrix. I take it from here using this mapping, type movie, title, field mtitle, which is the matrix. And then I have these two actors, Can or Riv, that acts in this movie. Okay, so simple, but you can imagine a more complex way. And also you can imagine with this framework, you can have this complex database with hundreds of tables, whatever, but then at the end, if what you are interested in are a few pieces of data here and there that you want to put, that you can describe with a few classes and properties, you can define mappings and provide a knowledge graph view over this complex database that uses exactly the class names and the property names relevant in the domain of your user. So your user will be able to formulate a query without having to look at the schema of 100 tables, which is completely unusable. Okay. Last but not least, we have the query language, which for an RDF graph is Sparkle. Here is an example of query in Sparkle. So give me all entities A. This is a variable. Was type is actor that plays in M. This is another variable. M must be a movie and must be a title, which is a variable. So I want to get the value of this variable. Now, the way Sparkle works is pattern matching, graph matching. This is called a basic graph pattern. You can think it as this kind of pattern where you have some nodes that are variable and you want to find substitutions of these variables with nodes that you have in your graph. So, for instance, here I can get the URI for the actor Keanu Reeves. Here I can have the URI for the movie The Matrix if I match it to the graph that is here. Okay, the language is of course more complex, so more expressive. So you have basic graph pattern, but then you can combine them using union, so either this match or this other matches. Optional to express things that may also not be matched. You can filter, so you can say, for instance, the movie must be like, the title must be like something. You can use aggregation with group by and aggregation functions, minus which is similar to the except of SQL. So you have a language that is quite comprehensive here. Okay. Now, putting all these four ingredients together, what we have is our user that wants to ask a query over my virtual knowledge graph, which is virtual, does not exist. The knowledge graph is given by the data source, a database, the mapping, and ontology. And we want to answer the query using these three ingredients combined together. Okay, I will go directly to the next slide and just tell you here that the solution is query answering by query reformulation. So we rewrite the query, we do some transformations of the query in a way that we can answer it from the database. So here is the framework with all the steps that starts from the user query that is expressed over the ontology and arrive to the answers. So let's look at the single steps. So the query is, give me all the entities whose type is play. Okay, remind in the ontology we said that movie is a subclass of play because maybe we have also television series, we have other kind of artistic works. Okay. The first step is to rewrite my query in order to account for the logical inferences that I obtain from the ontology. So if the ontology says that a movie is also play, I can rewrite my query in this way. So give me all the things that are play and union the things that are movie. Okay, so this is a way to rewrite the query, so to account for to implement the reasoning at query time and account for what can be inferred from the data. It's not in the data, but can be inferred from the data. Once I arrived here, I have rewritten the query using the ontology. I let's say, do the so-called unfolding, so I replace these patterns with their SQL definition. So here I match P type movie with M code A movie. A is an abbreviation for type, so here is like if I have a RDF type. So I select M code from movie and, okay, here, sorry, I missed where type is M. But basically this is the mapping that gives me type movie. I would like to do the same also for type play, but I don't have a mapping, so this will give me the empty table, union empty table with something, I keep just that something. So at the end, my SQL query that I will send to the data source is this one. I send the query, I get the answer, this is the answer from the database. Now I apply the ERI template, which is the template that I use in order to transform the tuples coming from the database into iris identifiers of my knowledge graph. So here I end up with the answer that is the IRI M511. Now, keep in mind all these letters because we have to abbreviate in this slide, so here you can have things that would be more expressive, more readable. Okay, all this framework is being implemented in a system that is called OnTop. It's born in UniBZ in my research group in 2009. The first research was done, however, in 2004, setting the foundations for all the process that I described before. It is compliant with many semantic web standards. Some of them I mentioned before, like RDF for the data, OWL2 for the ontology, Sparkle for the queries, some other things like GeoSparkle, which is an extension of Sparkle for geographic data, so there are different capabilities. It's done in Java. You can also use it via Docker if you want. There is a website with all the instructions, so if you want to play with it, it's not difficult at all. It supports different relational databases. Here I put some of them, and it is open source with quite, let's say, a good community that has been developed in time. So here there are some statistics. Then recently, since I think 2018, I don't recall the year, but basically there is also a startup, a spin-off of UniBZ that contributes to the development of OnTop using an open core model. So it means that the core of OnTop will always remain open source, and there will be contributions made by the company to the core. Then the company will also offer other services for paid to their customers. So how can you use OnTop? Here is, let's say, an overview. You have your data sources, you put the mappings, and the main use case is to create a virtual knowledge graph. So OnTop will give you the abstraction of a Sparkle endpoint, like the one you may get from a triple store, over this virtual knowledge graph. Then when a query arrives, the query is translated into queries to the data sources. And this query, you can use them wherever you like. So you can have your program, let's say, written in Python. You may do some data science project. You can have your scripts in Pandas, R, whatever. You can call it from the terminal, so on and so forth. There is also another, one thing before. Here I put different sources. Now, in the discussion I did it before, I was referring to one data source, but you know there are tools and techniques for so-called data federation, where you can take multiple databases or multiple data sources that you can adapt to a single data model, and you can federate them, giving the impression of having a single database. So you take Postgres, MySQL, and some other database, you put them together in a so-called virtual database. For doing that, you can use a data federation system. Here I put the name of two open source systems, TAID and Dremio. There are others that are commercial. These two work quite well, and we use them a lot in our projects because they allow to combine different sources at the relational level, and then over them we put on top to create a virtual knowledge graph. If you are not interested in a virtual knowledge graph, you can use the same pattern to have the data sources, the mappings, and then you materialize the knowledge graph. So basically, you generate all the possible triples, you put them in a file, and what you get is something that you can put in a triple store, and then you have your materialized knowledge graph. So the same technique, you can use it also for a materialized setting. Okay. Here, an idea of all the subjects involved in the development. So we have UniBZ, the startup, 7 other universities. We have also a company, Ontotext. Ontotext, they are the creator of GraphDB, which is one of the main commercial triple stores, and they are integrating OnTop in order to access the relational databases in their commercial product. So they are also contributing back to OnTop. So just to tell you, there are commercial companies that are involved or contributed to the project. Here is a graph of the Git commits in the past years, so it's quite active, and so you can really have support from the community if you want to use it. A list of projects, mainly research, but also industrial. Some of them I already told you before. So, OnTop in action, just an example. This is the query formulated over our complex let's say, scenario of Statoil about oil extraction. You see a huge query. Once you do all the mapping, you introduce the ontology, you simplify it with something like this, which uses terms from the domain. So this is something that, let's say, a domain expert, a geologist in this case, is more likely to be able to write something like this. And this was already simplified because we cut away some stuff that did not fit in the slide. Is not writable at all. Okay. There are different, how much time, sorry? Okay, thank you. There are several research and development directions that we are investigating in the university and the company. I put here some of them. So one of the most costly things to do when you want to deploy a virtual knowledge graph on a complex database is to define the mapping. So you have 1,000 tables. Maybe your ontology is simple, 2 classes and 10 properties. 1,000 tables, okay, you have to look at each of them and let's say see which one of them will map to the ontology. It's a complex task. We are working towards making semi-automated this activity, leaving a kind of bootstrapping where you have a tool that can generate a draft of the mappings and then you can do something on them. We are working on provenance and explanation. So here the point is the user gets a result from our system and asks himself, okay, but from which source this result comes from? From which mapping? From which axiom of the ontology? Which axiom of the ontology was involved in generating this result, also for debugging? So these are all things that can be addressed as part of the query answering algorithm. We have, moving on, the geospatial extensions I was mentioning before. Temporal streaming extension. You know there are so-called stream processors. Flink is one of them. Spark, you can use it also for managing streaming data. And a nice thing of these stream processors is that you can write an SQL-like query that operates on a stream of continuous data. Okay, since these tools support SQL, so which is a language we use, so we are also investigating, and actually we have an extension for creating a virtual knowledge graph on top of these tools that already provide this structured query formalism. And one of the main operations you do here is pattern matching. So you look at a certain temporal sequence of event, like let's say the pressure was low and then high and then low again. Okay, this may imply some particular event in my specific domain. So you try to match this stuff. And the point is now you can express it with the mappings and the ontology in the kind of extension my colleagues are working on. Then another huge area is to support sources that are not relational databases but are non-relational. So we did in the past an extension for MongoDB. There is ongoing work on Neo4j, a graph database that uses the property graph model, which is not RDF, it's a different thing. Web APIs is the one I'm more involved with, and the one I will tell you something in the next slides, maybe skipping some technical details because this part is more technical. Now, why APIs? Okay, here is, I think, a common situation. You have your application. Your application has its own data sources, so you can have one database, few databases, but increasingly, data is available through APIs. So maybe you want to access temperature data, weather data, whatever, that you access by calling some APIs. So you have data-intensive APIs that you may have to integrate when you access data. And all this integration, baseline solution, you have to do it writing your code. So maybe you start calling the API, then you do a query on the database, then you call again another API, and then you do all this workflow, you do it yourself. So this is quite an expensive task, okay? So this is what we would like to address with this extension. Now I skip all these statistics telling you how web APIs are important. Take it for granted. Now, I think yeah. Before telling you about what we are trying to do, I just give you a concrete example to reason on. Now, this is an example that maybe people from NOI may know something because I used it in the past. So let's say that we are operating on a data source. This is the Open Data Hub relational database that contains data related to the Bolzano province, open data, like data about accommodations, weather, so on and so forth. And we want to combine it with an API for semantic search to ask queries like the following one. a query where we ask for all the accommodations and their properties like the description, rating, so on and so forth, where the rating is 3 stars or more, and this is a structural constraint, so I'm looking to a specific property of this item, and I want this property to satisfy a certain crisp criteria, greater or equal than 3. And then I want also its description, which is a piece of text, to match a search string. Here I say horse riding. I'm looking in some accommodation where I can try riding horses, but I can also look for nice panorama, whatever you like. And for doing that, what you use is a search engine. Here we want to be fancy, so we use a semantic search, a form of search, where you try to capture the meaning of the text, and instead of doing plain term matching. So let's say nice panorama can match, let's say wonderful view nice Dolomiti panorama can match a wonderful view of mountains, because the two things are semantically similar, even if you don't find any term in common between the two texts. Okay, let's say that you can build an API of this using, let's say, libraries and resources that are available. Here I mentioned BERT as a language model that you can use for that. So for people into NLP, this is stuff that is done there. And you want to answer this query, API and database. Okay, so look here, we have the database, we have the API, we need to access both of them. Now, the solution we would like to investigate is the following. It's a solution where you don't have to access these two sources yourself from the application, calling the database, calling the sources, okay? But you want to access them through a virtual knowledge graph. A virtual knowledge graph that allows you to express a single query that is then sent to the sources by the machinery providing the knowledge graph. So the complexity, we wanted to do it ourselves within the on top and whatever we combine on top with. Now, in this case, we are looking for a solution done by two components. So first of all, we use a tool for federating the different sources, the database and the API, into a virtual database. And then on top of the virtual database, being it a database, we can put on top and we can provide, let's say, a virtual knowledge graph on top of it. So this is a straightforward way to operate, but then we are also looking in the way that this component, so on top, can be optimized, knowing that underlying this component, we have a virtual database that has some restriction because there are APIs that are being called. Now, look at one thing. The API is not a relation, it's not a table, but we can, let's say, provide a relational view over the API. Now, I will skip a bit because over the technical detail and, okay, give you an idea of how this can be done. So first of all, this virtual database, we can use standards for defining it. SQL-MED, which stands for Management of External Data, is one of them. So look here, create a database virtual DB example. In this database, I declare that there is one DB source, create server DB source, which is accessed through a wrapper that is Postgres. Another source that is accessed through another wrapper that is called service. This is something that we are developing. They have two schema, DB source and SRV source. One from the Postgres one DB source is imported automatically. You know, if you access a database, you can get its schema. It's easy. For the API, we define it ourselves. Okay. And we do it this way. So we map every API procedure to, operation to a procedure. Like, for instance, the semantic search procedure, we get a query in input, and we produce in output a table of these attributes. The query itself, the identifier of the accommodation we matched, the score, the text excerpt that matched it. Okay. Then we introduce tables, virtual tables, that are based on these procedures. So we say we have a semantic search table of matches, query, this, score, excerpt. These are the same attributes. If you do a select over this table, you have to look here. This select, you can implement it by calling this API, this procedure, which is an API operation. So if I write select star from same search match where query equal horse riding, what actually I will do is to call this procedure with a query that is horse riding, because it comes from the where condition. Okay, this is the intuition. Then I will skip a bit some of the details just to tell you, after we do that, we can take a complex SQL query that accesses both the virtual table of the API and the real table, and we will have our data federation system to come up with an execution plan where on one side you have the sub-query that you sent to the database, give me the identifier and the name of the city from the accommodation. On the other side, give me the matches from same search match. This is the API. So you have two access operations, and then on top of them, you have the usual stuff that you do during query processing. So you have a relational algebra tree, you have a join, you have a projection, a selection, so on and so forth. Okay, so the tricky part is to map the API to a table, two tables, and then make sure that when you call them, you do it in an optimized way. Okay, and these optimized ways, you achieve that by making sure that you push down to the API, you delegate to the API as many processing as possible. So if your API have query parameters to do filtering, have slicing is the same as pagination, let's say. So I want the top 10 results, and I have a way to get to tell the API, give me the first page of 10 results, then I push them down. Okay. Also, if your API has so-called bulk operations, so give me all the persons whose identifiers are either ID 1, 2, 3, 4 in a single call, we have to leverage also them. Here are some details of why we have to leverage them. Okay. In all this framework, you have to account for some API operations being expensive, and for that you can do materialization restricted to these operations. You can use materialized views, given, for instance, by TADE. We have also a solution which is somehow more, let's say, flexible, where you can have a materialization engine that applies rules according to some execution plan that take into account the dependencies between rules. So this is technical stuff, okay? But in this specific example, it is used to populate this index of the semantic search engine. Okay. Once we have the VDB, I was telling you about the VDB before, so far, up to now, we put the VKG on top of it, usual stuff. So we have the ontology, and the ontology we also model the data, the match that comes from the API. We have the mappings, and the mappings, they also cover the data from the API. We submit a query to the VKG engine on top in Sparkle. This engine on top will rewrite it in SQL, then this SQL query will be executed by TADE by calling the API. Okay, so I don't know whether we have time for the quick demo. I'm watching you, Francesco. Okay, okay. So just to tell you that this stuff do exist. So if we go here, it's open the tab portal is a prototype. We click on Hive Fusion Grant project. There is an example query. If we run it, well, it was already run before because we tested, of course, before the talk. You get the list of accommodations with their iris, the label, in this case, the description, and the score. On top, it also gives you, besides this tabular view, it also gives you the geographic view using an extension. So this is an open source visualization tool that we integrated. So if you click on one of these points, which is an accommodation, you get the description and white matched your query. Okay, so that's it. This part gives you an idea of how a certain Sparkle query is rewritten into SQL query, but I don't have, let's say, I don't go much into details. There is a developer, let's say, API that you can use on top for asking on top, how are you processing this query? And then it will tell you, look, I will submit this SQL query to the database, and then you can do debugging. Okay, going back to the slide. So this is the overall framework I described to you so far for calling APIs, where I'm showing the picture of before, and I'm also showing that you have an ontology, where the ontology is, the ingredients, the mappings, the materialization rules for the expensive APIs, and the so-called API bindings that are this mechanism by which you say this API operation is this procedure that goes into this virtual table. Okay, one important thing is that we are focusing on the virtual knowledge graph point of view, but you can drop all the part above this arrow, and you can just look at it as a virtual database. So you can, if you are interested in accessing all this stuff via an SQL query, you can use the extension we are working on for that. So it's workable also outside a virtual knowledge graph setting. Now, final slide. Takeaway messages. So virtual knowledge graphs, what they are: a flexible technology for building a knowledge graph over data that already exists. You have your database. I can get a knowledge graph, a virtual knowledge graph over this database. The data resides in the database. When I do a query, the query becomes a query on the database. So all the processing is done in the database. I don't have to buy another server, put data somewhere else. No. Okay. You can use, however, this technology elsewhere, because you can use it, for instance, for materializing some existing data into RDF. Or there is another use case that is, of course, in some projects we are working on. You start with some data that is inherently relational. By this term, I mean it's data that mostly you can describe with some tables, but still you want a knowledge graph. So there are these scenarios. And in these scenarios, what we observe is that sometimes using a relational database with, on top of a virtual knowledge graph engine over it is more performant than using a triple store, because a triple store will store your data in triples. You ask a query joining 10 triple patterns, these are 10 joins. But maybe this data can be stored in a single table where the relational database will build some optimized indexes and it will go very, very fast. So really, if your data is mostly relational, you may also consider this trick. On top, as I say, this mature system for implementing virtual knowledge graphs. And we are extending it to web APIs, among other possible sources. So I would say that's it. And you have the links here. Thank you.
Cool. Thanks for the presentation, Francesco. We have a few questions. If you want to ask some more, go to slide.do/st47. I have to be honest. He was my esercitatore. If you remember, back in the days, we had Locinio, who was my professor. No, I still don't understand anything about networks. I still understand very little about DBs. So you have to bear with me. We got some questions first. Why are the data sources supposed to be read only through the VKD layer, or can they be changed using the VKD language?
Okay, so changing the source is something that is not supported right now, in the sense that it is a tricky problem, because it is related to a problem known in the database field as a view update problem. So I have a view over some tables, and what happens if I do an insert or an update over this view? Well, if the view is simple, it works, which in our case, it means if the mapping is simple, it works. In general, it doesn't work. So it's not defined exactly what you have to do, because, for instance, you may have a mapping that just extracts 2 attributes out of a huge table. When you add something to this, using this mapping, so you add some triple, then you say, okay, I have to add a tuple, to the big table. I know 2 values for this tuple, but all the rest, I don't know what to put there. So in general, don't.
Very related to that, can these knowledge graphs deal with missing data? E.g., I ask for plate and colors of cars made in 2017, but one database has only the license plates and the year of making.
If I get the question, so
it might also come from home, people watching on YouTube, yeah. Who asked this question, maybe, if you want to integrate.
Okay, good. Yes. Mm-hmm. What will happen? So in your case, you have a kind of so you can have redundant information in the two databases or complementary information. So in both cases, when you use this technology, you can leverage this information. So you will ask a query, so give me the cars with these characteristics and give me these properties. This query will be probably executed as a union of two subqueries to the two databases. Maybe in one database, you will extract all the information you need. In the other one, there is no match. Or in the other one, you extract the missing fields, so complementarity. Or you extract just a subset of the attributes you want, but then I can tell you when you put together these two subqueries, there is a distinct, so on the single attribute, so at the end you keep the union of the information you get from the sources. So somehow the kind of scenario you are saying, in general, it is handled.
Got it. In case, just ask me after the event, after the talk, okay? Why is that most of the tools you showed us in the beginning, like SparkQL, etc., are still recommendation and not standard? Is this a matter of consensus?
They are synonyms. For W3C, a recommendation of W3C is a standard.
Okay, got it.
Because the step before is a candidate recommendation, so there are several steps, but when it is a recommendation, it is a standard.
Okay, could there be any security issues?
Not more than respect to querying a database. So if you have problems, privacy problems, security problems with accessing data in a database, you have the same problems in the virtual knowledge graph.
Got it. How do recent advancements of machine learning, like text embeddings and transformers, impact this more structured approach to text mining?
So here it was an example of API. So the two things are separated in a sense. Then I'm not saying that, well, you can use machine learning in a sense to address some data management related tasks. It's not exactly what we are addressing here. So the two things are distinct. So, I mean, just to give you some pointers, you can use machine learning in order to optimize a query. It's not text mining, whatever, so it has nothing to do with the natural language. If you focus on natural language, there are tasks where you want to convert a query in natural language to a structured query in SQL, Spark, or whatever. It's another related task, but it's a different task from the one of, I already have the structured query and I want to answer it. So these are all complementary tasks for which you may use machine learning.
Final question, which is maybe a provocation. What happened to the semantic web pictured by Sir Berners-Lee?
Wow, it has become quite old. I mean, I'm not probably the right person to tell you what has become of it. So it has evolved. Let's put it this way. So, I mean, I remember the first paper, which was about all these intelligent agents and scheduling the visit at the hospital and whatever. So nothing of this exists, I would say. But let's say a lot of technologies, they do exist and they are useful, even if maybe not used in the original sense of making the data on the web smart. So there was an attempt of it. If you look at the linked open data cloud, linked open data movement, they tried to do that, although they started from, let's put the data on the web, even if it is not exactly smart. And I don't know whether they moved forward from this step. But still, there are a lot of things that have become useful in practice. So,
cool. Thanks, Francesco. Big applause.
Thank you.
Okay, now, quick break before moving on to the second talk. We've got a few things to show you because these days there are a lot of important things happening at Speck&Tech. First of all, we welcome on stage Eduardo from the board, the organization of Speck&Tech, who has an initiative that they have just launched. So, ciao Edo.
Hi everyone. It's nice to be here. I'm here as a photographer today, not as a presenter. But I wanted to present you this event that we launched like a few like we've worked on this for quite a long time now. It's an experiment. We've never done something like this as a Speck&Tech, but since we're always focused on a young community and we always work with you guys and other people that are close by our our communities, so students, entrepreneurs, designers, and whatever. For the first time, we're trying to have an impact on our territory, on our city, on Trento, and on the places that we live in every day and that we work in. So we're trying to help elderly people, not necessarily like really old people, but just people that are not really too good with their smartphone or with their tablet or whatever, and need to improve their skills, need to learn this kind of language that we all speak very well, I think, but like for them it can be difficult, it can be a struggle. So we are trying to do that. We are doing that with the 3 events. They are like different. They have different topics. The first will be on like smartphones. The second will be on internet and scams, phishing, cookies, advertising, and how to deal with all of that. And the third one will be about applications, how to download, install applications and stuff. Very basic stuff for all of us, I guess. But like as I said before, it can be really a struggle for other people. So we really are passionate about this project that has a social impact. So if you have somebody in your family or like in your group of friends or whatever that you think could be interested in this kind of initiative, please tell them to sign up. It's free, as everything we do. So it's going to be on Saturday, next Saturday, the one after and the one after, 2 hours in the morning. There will be a theoretical part with us. Cesco, which is there, will be their teacher. There will be a practical part of around like 1 hour to half an hour, kind of a workshop, a lab. And if they have problems, they won't ever bother you again with installing apps or like unsubscribing from payment services or whatever. And they can come and bother us actually. So like it's also a chance for you to get some more free time and delegate these kind of problems to us. So but really, if you have someone that you know that could be interested in that, please sign up them for you can text us an email or drop us an SMS or WhatsApp or whatever, or even for them, if they don't know how to do that, you can do that for them. And yeah, so that's it basically. I hope to see some of your parents or grandparents or whatever, grandparents and down the line. So yeah, thank you guys and enjoy the next part of the evening.
To say it in other words, one of my biggest nightmares is my aunt coming to me saying, tu che sei un informatico, tu che hai studiato informatica. If you have that nightmare too, please go to your grandmother, go to your aunt, and tell them about this event, okay? We will share more in the next days on the social media. Okay, this was one. The second one is, it's a bit weird here, but we are very soon launching our next event, which will be the final event of the year. And it's going to be either on the 12th or on the 14th of December. It isn't decided yet. So you can book both nights if you want to be there, be sure. Also because it's going to be like a Christmas event. We're going to have a Christmas tree. We're going to have maybe brulee. We're going to have some shiny stars. And it's going to be beautiful. So please remember these days. We will tell more on the social media soon. And final one, I promise it's going to be the last time you will see this video, but there's going to be something happening very soon. So.
Never felt so high like this before. Am I hallucinating? I just can't be sure. So won't you come closer? 'Cause I've got to know. Are you looking for somebody just like
Tasty.
Affettato. Si sente?
Sauna.
relax.
I've got you in my veins. Baby, you know what you started and I can't breathe.
Speck&Tech, amicizie nuove e gite insieme.
Can't turn away.
Speck&Tech per me significa casino genuino.
I just gotta have a taste. Lock me up and throw away the cure. Ain't no remedy once you take control. I try
Fantastico.
to resist you, but I want
Famiglia.
more.
Community.
Networking.
That is your kiss. I'd do anything to taste you on my lips. My dark obsession.
Donks, donks.
I can't quit. Now I'm hooked on the sensation. I can't escape. I've got you.
Figata.
Baby, you know what you started and I can't breathe. Girl, you know I want you. You got my attention. I can't turn away. Girl, you know I can't help it. I just gotta have a taste.
So this was the after movie of the second edition of the retreat. It's gonna be the last time I'll tell you about because we're gonna have the event in 3 weeks, something like that right now. So it's things are getting very, very serious. It's gonna be on from the 2nd to the 4th of December. It's gonna be a weekend in the beautiful Val di Sole. This is the program. You can find anything on our website. I'm telling you right now because we have 50 seats that went sold out. Then we increased. Now we are getting to 70, and we are 65 at the moment. So there are 5 tickets left. Till Friday, we're gonna have a professional price, €160, and if you're a student, there's 1 ticket left for 120. 5 seats left. The registrations are closing Friday, 23:59, maybe earlier because they might be sold out. Last time I told you about this. Second talk, Tobias on stage.
Okay. All right. Nope, that's wrong. Wrong direction. What the fuck? Nope. Oh yeah. Okay. Yeah? Com'è? Ah sì. Se è possibile. Yeah. If at all possible, I'd prefer not having that extra bar there. Full screen no? Non ce la facciamo? Ah, no, infatti non funziona. Nope. Ma non c'è full screen? Ma un Mac. Ma scusami, su come si chiama? Preview non va? Ma c'è la barra? Chi è che si intende di Mac e PDF? Nessuno. Dai raga, sala piena di informatici. Aprire un PDF senza la barra sotto, dai. Oh, scusa. Bello, dai, mi sa che ci siamo. Ottimo. Bravissimi. It's great. All right, so hello. Great to be here. My name is Tobias, and I'm here to tell you why the computer you're using right now is too good. You should get a worse one. Back up a little bit. So I'm Tobias. I'm originally from this region, actually. I'm from Provincia di Bolzano. So this is kind of like a home event for me. But I've lived in Germany for a number of years. And what I mostly do is I work on GNOME. So if you're not super familiar with the like GNU Linux free software area, that's like a free desktop. That includes everything from like the settings app to the file browser to the thing you use to switch windows. And like I'm basically involved with the design of all of these things. And this is kind of what it looks like. Also, can we get rid of the cursor? Yes, great. No, fuck. Never mind. Made it worse. Okay. Where was I? So yeah, this is what it looks like. It's very cool. You should try it. There's a thing called Fedora, which ships a very nice version of it. I would recommend it. But so that's not really what this talk is about. This is the free software edition of the talk, but I'm going to be mostly talking about things that are going in a slightly different direction. Because when I work on GNOME, we're using a thing called GitLab, which is this web tool that you use to like file issues and do merge requests, and that's what we use for reviews and like planning and all kinds of things like that. And if you use something every day, it's a bit annoying if it's very slow. And one of the problems that you have if you use GitLab all day, you look at a lot of screens like this, where like some of it has loaded and the other stuff is like still coming in, or things like this, where it like loads the body of the issue, but like a whole. Is the audio fine? Yeah. Okay. But like all of the extra stuff, like images take a while, and like sometimes like in order to actually get the full thread of issues, like you wait like 10, 15 seconds, and that's very annoying if you do this 100 times a day. And then yeah, sometimes it's just like literally a list of things, and for these whatever 20 fucking paragraphs of text, like it takes 15 seconds, and you're like, what is happening here? Like, how is this even possible? And then of course it's not like limited to like code-related things, right? Like. Let's say I want to complain to friends about the GitLab being slow on Signal. You get this shit for like 20 seconds, like downloading 400 messages. Like, what are you doing? And yeah, like, then I want to create a document of like listing all the slowest apps, and you get this stuff. It's a whole checkbox list of being slow. And I don't want to like shit on these projects in particular because it's really everything, right? I mean, like these are the examples that I'm confronted with a lot, but like. What I hear from people like using the proprietary stuff, right? Like the people using Teams and Slack and so on, like they all complain about the same stuff. I can't personally confirm, but like that's what I'm hearing. And it's a bit weird because like we're at the end of like whatever how many decades of like Moore's law, the number of transistors like doubling every X years, and like everything should be fast, but it's getting slower. Like what is happening? And the analogy that I'd like to make here is a historical one, where like in the middle of the 20th century, people thought cars were a good idea. I know we've moved on since, but you know, it was a different time, and they like started doing a lot of things with cars. They like started buying more of them and using them more, and so the very limited road networks they had started becoming congested. And so people were like, okay, maybe we should have more roads, and so they built more. And they built a world that's mostly made of roads and not made for people, but for cars, which has a lot of other issues with it. But interestingly, it also didn't resolve the traffic problem. Like the traffic is worse than ever because, like you know, when you just add more roads, that doesn't necessarily like you know mean that the situation just changes in that one way. It changes in a bunch of other ways as well. Like if there's a new road that gets you to this place quicker, maybe you drive there more often. Maybe you drive more in general. Maybe a lot of other people had the same idea, and then you get even more traffic. And there's actually a paradox, like coined by this German mathematician that basically goes like this. Adding extra capacity when the moving entities selfishly choose the route can reduce the overall performance of the whole system. Which sounds counterintuitive, but apparently it's a thing. Like they did a whole game theory thing about it. And I mean, you know, it's a bit of a strange analogy, but sounds familiar, right? Like we're adding more and more and more like power to all these computers, but they're not getting better. Like the actual experience of using them, in some ways, is getting worse. And I think we all sort of know the culprits, right? It's because everything is running in the browser now, and like if not in the browser, then people are shipping their own browser in the form of Electron, with their like 2 megabyte app, they're like shipping a 200 megabyte browser, which turns out to not be very efficient. And of course, I mean, there's a reason why, right? Like, developers are expensive. And so instead of like 3 people building 3 native apps, you have like 1 person, and they're making a website. And you know, you're basically like having people pay for it. Like, you're externalizing that developer cost to people, like having to buy new computers every few years. And I think like there is sort of a there's sort of like a equilibrium that people are optimizing towards, where like there's a certain amount of shittiness that people are willing to accept, that people are willing to live with. Like, I'm not sure, I mean, probably most of you do not remember this, you're like all 17. But like, in the old days, there was Internet Explorer, and it like used to download whatever malware. And like every piece of malware you added, like added another toolbar. And I think like sort of, I guess the analogy here would be like, there's a certain number of toolbars that you're like willing to accept, and then at a certain point you stop using the thing because it's like literally unusable. But I think it's the same with this Electron stuff. Like, there's a certain amount of slowness that people like are sort of learning to accept, and people will just optimize for that. Like, sort of, how shitty can we make it while like basically saving money and like forcing you to buy a new computer every few years? But the thing is, it really doesn't have to be this way, because not everything is like this, right? There are examples in the world that exist today and that people are using that don't do this. And I think an interesting one, especially like in the chat space, because that's where most of the things that we were talking about before are, is Telegram. Because like they have 4 different native apps, right? They have like all the mobile ones, plus like 2 desktop ones, like 1 specifically for the Mac. It has a ton of features. It works on like Wi-Fi connections where nothing else works. It has great UX, and somehow they're doing all this. And like no one else can do it. But it is clearly possible, right? But I think the even more interesting, the more interesting case for this is looking at hardware. Because with hardware, like, okay, yeah, but clearly, you know, hardware always gets faster, right? And so obviously the hardware from 3 years ago, that's shit, because the current hardware, like, way better. But I think that is also, that's also like a weird way of looking at it if we look at it with these 2 examples that I have here. The first is the Samsung Galaxy S9. This was released in 2018 as like the #1 like flagship phone, like whatever, $800, super expensive, super premium. And it was released in February with Android 8. And then it received 2 updates to new major Android versions. And then in 2020, 2 years later, they basically stopped. And then it got like security updates, whatever, like every N months. And then earlier this year, as far as I can tell, they've stopped security updates even. So now it's basically trash. Like, not even 5 years later. It cost fucking 800 euros. It cost, at the time, fucking 800 euros. And probably the processor in there is still good. It's just we're not updating it, right? Like, it's all in the software. And I think the interesting counterexample is this phone, which is the Librem 5. That's the phone that a company I work for makes. It's basically like the complete opposite in the sense that like, maybe like to back up a little bit, like it's a phone that actually ships like mainline Linux, right? Like it's not like those Android kernels that like have a billion patches and custom everything with like binary blobs. It like actually tries to be free software. And that means you get to benefit from like actual upstream development. And that means it takes a long time to actually write those drivers, but once you've written them, then you benefit from the entire ecosystem. And sort of the interesting difference in timeline there is that like in 2018, when the phone was like, there were basically like early production runs that barely worked, like the software was nowhere near like actually usable. It was running super hot. But like over time, as people like actually did the hardware enablement for those things and actually like upstreamed all those drivers, it started getting to the point where with like upstream kernel, with upstream GNOME, with upstream like all of these components, everything sort of starts moving in the direction where it actually works. And in 5 years, it will run better than today. Because, like, for example, like the software stack that the Librem 5 ships with doesn't use GTK4 doesn't use GTK4 yet, which is the new version of the toolkit that we have in GNOME, which will like make everything a lot more performant. And once that drops, the usability of the thing will magically just get way better. And so currently, the Galaxy S9, yeah? The Galaxy S9 is already like out of support. But this thing will still be supported in 5 years' time. It will be a lot better than it is today. And I think like there are a lot of like other factors here, but I think my point here is that hardware becoming like trash is a choice. That's not something that happens by itself. That is something that we do because we make certain choices in how we support them, in how we write drivers for them, and so on. And so with all of that in mind, here are some provocative suggestions from our good friend over there. So step number 1, get a worse computer. As a developer, like the experience that you have developing stuff is super important. Like that is your baseline, that is what you optimize for. If you have 64 gigabytes of RAM, like no matter how many whatever processes you have to like try and optimize for shittier hardware, you will never care about it as much than if it impacts you. And I think this goes across the board. So step 1, get a worse computer. Step 2, don't upgrade your hardware to run the software that you want to run. Upgrade the software to run on the hardware you have, right? Like, I mean, it goes together with the point from before, but like, it's a completely different shift. It's a complete shift in mindset compared to like what we're used to doing. It's like, well, obviously this thing isn't working, so I need this new computer. Well, not necessarily. If you use software that you can contribute to, which is not all software, right? If you use Windows or whatever, then like you're limited in in that sense where you can't contribute to it, and if it doesn't run on your machine, then that is what it is. But that is not all software, and a lot of software you can contribute to, especially as a developer, you have a lot of those options. Do lower level things. Like, no one needs yet another like React thing to render HTML pages. Like, there's enough of those. But like, actually optimizing the hardware that you have to run better, like with, I don't know, like better power efficiency. Improving the Wi-Fi drivers, improving something in the networking stack to like be faster at connecting. Like there's so much interesting stuff at those lower layers that you can contribute to, that you can work on. It's probably not actually harder than like the insane complexity that you have in fucking like JavaScript bundling these days. Like it's just a matter of like how you look at it. And you know, it's a slightly different culture. There's like many different factors, but like I think seeing that as a possibility, like seeing the lower levels of the things you're running as something that you can actually access and contribute to, I think is an important aspect of this. Be like Telegram. Write native things for every platform. Don't make shitty web things. I mean, it sounds easier than it is, but like, you know, or it's harder than it sounds, but that I think is something that you have to take seriously, because like otherwise we'll just keep piling layers of abstraction on top of other layers of abstraction, and stuff just gets slower and shittier. And you know, in 3 years people will be like, oh yeah, like that M1 that you're running, that's horrible and old. Like you need to run at least the M4 to use my chat app that renders like 17 lines of text at a time. It's like, okay, I guess you can do that, but it's really not a nice way of using all of this hardware. And if you are building websites, I mean, this is a personal thing, but like this is how I've built websites the last 6-7 years, which is no build system. So like if I open the project again in fucking 5 years, it will still work because there is nothing, there's no dependencies, there's no like weird, I don't know, JavaScript thing that like downloads a bunch of things on the fly. It's all like in the folder. It's all right there. It's some HTML files and some CSS files. No frameworks, no like weird syntax or whatever like Tailwind thing that you need to remember. It's just standard CSS, like or a few HTML files, a CSS file. Works great. And no JavaScript, because really, for the most part, that is where the slowness comes from. And also, you don't really need it. Like, if you actually embrace the constraints of the web, you can do a lot of really nice things with just HTML and CSS. But yeah, of course, like there are slightly different things than like small information pages, which is what I mostly build. But you can do very fancy things with very simple tools. But really, like hammering that point home, embracing constraints is so interesting. Like, if you look at, I don't know, like the games market, I think is really interesting. Where like Nintendo never really like has the fanciest hardware. They never have the fanciest graphics or whatever. But like they combine the constraints that they have in cool and interesting ways that are often like better than whatever like super high resolution things that they have on the other consoles. And I think especially like if you look at stuff like retro games, right? Like people use the games or play the games still that are from like 40 years ago, and they're cool because within those constraints they make really cool things. And I think that is something you can do at every level within any kind of like technology stack. And so just in general, try and use less of every single resource. Like, think about every resource that you use in the software that you make, in the, I don't know, like every architectural decision, every content decision, and so on. Think about the resource that you use. Like, does this use more CPU? Does it use more storage? Is it gonna like increase whatever the load time? Is this like too high resolution for what I need? Stuff like that. And like maybe to hammer it home a little bit more, does anyone remember this quote? Like, it's attributed to Bill Gates from the 80s. Apparently he didn't say it, but like I think a lot of people know it. Like, I think at the time the idea was that like he is supposed to have said that like this and this amount of storage or RAM or whatever it is supposed to basically be enough for anyone forever. And of course people now are laughing about it because like, ha ha ha, this is of course like 640K is not enough. Like, we've seen since that we use like 1,000 times more today, or however much. But I think in a lot of areas, we are actually reaching the point where a certain amount of X resource is enough. And so maybe provocatively, I'd posit it like this. For a lot of things, do we need more than 720p? Like that music video that you're watching in the background that you're not even paying attention to, does that need to stream in 4K? I don't know. Like a lot of things, do they even need to, I don't know, have any video at all? And I think like thinking about resources in this way, like how much do you really need of everything? And like if you think about the human eye, like how much resolution it has at a certain distance, like for whatever like the current use cases that you have, like how much of that is needed for the current use case? But really, I mean, so all of this, like, yeah, stuff is slow, like we're annoyed by whatever, like Slack being shit. I think all of that's kind of beside the point, because there's a much bigger reason to think about this, and that is, that's right, the climate crisis, everyone's favorite. Before I go into the second part of the talk, I need to have a quick trigger warning. If anyone feels like they need to take a break right now, like that's fine. Yeah, you've been warned, but this is going to get a bit depressing. I don't think I need to tell you how bad the climate crisis is. We all know things are very fucked. We're seeing just like immense amounts of misery today in the global south and beyond, right? Like, I mean, this year in Italy, we've seen insane things that we didn't imagine were going to happen, like in this decade. And especially like if you look at the fact that a lot of those things are already locked in, right? A lot of these effects we can no longer avoid because like the emissions that we've already sort of are already in the atmosphere are going to continue to make things worse for quite some time, regardless of what we do. That is a heavy fact to to keep in mind, and especially this year, we have had this new IPCC report that basically says, you guys, we have 3 years. Like emissions need to peak before 2025, and then they need to go down like until for the next few decades in a stable way. And that is really, really hard to do, right? And I think it's really difficult to square that with all the other stuff we do, right? Like we're building websites and we're like making apps and whatever, building devices. And in the meanwhile, there's like this clock ticking there in the background where it's like, we got like 2 more years. You know, what am I gonna do in the next 2 years? But I think like practically thinking, because we are technologists, most of us here, like what are the things that we need to do in that time, right? We know that technical solutions are not going to do shit at this point, right? Like, I mean, there are things that we can and need to do there, but like that isn't going to bring the kind of change that we need on the timeline that we need, right? I mean, obviously, you know, having more resources in certain technologies and like pushing certain things forward, very useful, but like that is not going to that's not going to cut it. And neither are like lifestyle choices. Of course, yeah, I mean, nobody should be flying or eating beef or whatever. Like there are certain luxury emissions that are even on an individual level problematic, but like that is also not going to move the needle when like 70% of emissions are done by like 100 companies or something, I think. Like it's a really insane statistic. What you really need is actual structural change, like on the level of like, cool, we're going to shut down the car industry. Like that is the kind of shit that you need. And we're not going to get that with the current political institutions, right? Because they've known about this for 50 plus years, I don't know. And emissions have only gone up. Like, we know they can't handle it. And so we basically know that unless we get political change within the current system, because we're also not going to destroy the state in the next 2 years. I think we all agree that that's unrealistic. So if we want to try and do something within that framework, we need to force the state that we have to do drastic things in the next few years. And so the strategy that most of the activists I'm aware of who have like a large-scale plan for this follow is this: you mobilize a small but like not sort of insignificant percentage of the population, like a few percent. You do massive resistance, and you block enough of the economy that the government can't ignore it. And then you need to force the government to actually institute a democratic way to make the changes that are necessary, right? Like, because if you just impose those things from top down, probably you're going to have a bad time like getting people to accept them. But if you do it in an actual democratic way, like a way where democracy can decide over how resources are allocated, which is not what we can do in our current democracy, because like a lot of the big actual economic decisions are being taken by private industry, right? Or by the lobbyists paying the lobbyists from private industry paying our politicians. That is why you need some kind of like actual democratic control over those aspects. And that is why I and many other people glue themselves to the street regularly. That's me over there in a highway blockade in Berlin a few months ago. So this is with Letzte Generation, but like I'm also involved with Extinction Rebellion, and there's various other groups doing similar things. Like I know in Italy, like there's also Extinction Rebellion. There's actually someone from Extinction Rebellion I met earlier here. That's and there in the back. Shout out. And depending on the area, like there's different groups doing this. I know there's Ultima Generazione in Italy too, but I'm not super connected. But so like all of this other stuff aside, like I would really recommend looking into what civil resistance groups there are in your area. As far as I know, there's XR. I don't know about others. And getting involved, because otherwise all this website shit, kind of irrelevant, right? And also because if we don't manage, then we have to really think about what comes after. Like, what does collapse, as science tells us it will happen if we don't do this shit? What does that mean for the work that we're doing, right? Like, what does it mean for our apps? What does it mean for the work that we do every day, right? If we have no internet, if supply chains collapse and we don't get new computers, then like all of the stuff we were talking about with like whatever stuff working on old computers becomes extra relevant because there are no new computers. That is all you have, right? If you only have power a few hours a day from like a solar panel or something, that becomes a completely new consideration, a completely new appreciation, I think, for resource limitations. And yeah, of course, you're not going to like npm install anything if there's no internet. So there's a lot of things to think through there, like both like, emotionally, I think, like mapping this onto the timeline of your own life, right? Where am I going to be like when stuff gets real? But also like just from a purely technical perspective, like how am I going to build apps when shit gets real? And so that is, I think, where resilience also at the technical level really starts becoming an interesting question and an important one for all of us. But to close this, because I don't want to completely take away the talk that I'm going to give on the weekend at SFScon, a few takeaways. Slow software is a choice. I mean, it is an economic one, and that's important. However, it is a choice, and you can make a different one. You can make fast software. You can make nice software. If you generally don't use the web platform, like use GTK, use Qt, use whatever native toolkits the platform gives you, and you can make very, very nice things. I know because I do every day. Like at the GNOME project, I think we make some very, very nice native software. But in general, like build resilient software that doesn't use a lot of resources, that optimizes for these cases where, yeah, like no internet, limited power, stuff like that. And join whatever local resistance groups you have, because really none of this matters without that. And yeah, On Saturday, as I said, I'm going to give a talk about an adjacent topic, like going a little bit more into the technical aspects of resilience. It's this Saturday at 12, at the 12th at 9:20. And yeah, see you there. Or if you have any questions, shoot. Thanks.
Thank you so much. Okay. Thank you so much. It was a really amazing talk. And we have a few questions from our public. Do you actually use GNOME?
Well, yeah.
Okay.
What is the hypothesis? What else should I be using?
I don't know if the author, one of the author or the people who puts the thumbs up wants to add something. Okay.
I've also used GNOME. It's just too hefty for the system, in my opinion. And so I just use Hyper, for example.
I mean, good luck connecting to Wi-Fi over the terminal.
I've been able to do that. So
Yeah, fair enough.
It was quite difficult.
Okay. What do you think of Fairphone?
I mean, I used to have one. I had a number of problems with it. I mean, like on the sort of like I don't know. I guess fitting that into this framework, like that is unfortunately running Android hardware, and so it has all the same problems that like the Galaxy S whatever has, because it also for the most part like has these custom like sort of versions of Linux, and like everything like has to be patched for the specific chipset. And so, like, you can't run real like Linux on it, and so they need to do a fuck ton of work to actually forward port, sort of like make those devices run with newer Android. And so, at a certain point, I think also for them, it's like not sustainable anymore. I also have some other qualms with their specific hardware, but I won't comment on that.
Okay. What's your take on Graphene OS?
Graphene?
Yeah.
I mean, same thing, like the Android stack is fucked. Like we can't keep going with that. Like we need something that actually is like free software, because all of this Android stuff, like if you never upstream stuff, you always have to backport stuff. And I mean, it is cool for now, but like hopefully in a few years we don't have to do it anymore.
Okay, and really voted question. Which computer do you have?
I mean, I work for a computer company. I have a Librem 13.
Okay. Why does the GNOME shell source use JavaScript?
Why does it use JavaScript?
Yeah.
I don't know. I mean, it's been using that since whatever 2008. Like I've joined the project in 2015. I have no idea. I mean, like as far as I know, like the part that uses JavaScript is mostly like the less important stuff, such as like arranging the UI elements a bit. Like all the performance critical stuff is written in C. So I don't know. Make of that what you will.
Okay. Is the GNOME one of the heaviest desktop environments source-wise?
Sorry, what?
Isn't GNOME one of the heaviest desktop environments resource-wise?
Resource-wise?
Yeah.
I mean, I've never done any performance testing on it. I can't comment on like whatever numbers, but it's gotten like astronomically faster in the last 5 years. I'm not sure how that compares to others, but it runs on fairly old stuff now, and it like I mean I know people who are doing tons of performance like optimizations right now, so I'm guessing in like 6 months it's going to be a lot better. But I'm also on the design team, so.
We are in a point of no return. Even though we start a mass revolution, probably they, the big ones, would just shut us down. But do you think you don't think like this? Why?
Sorry, that they will shut us down.
Yeah, the big ones will just shut us down. But you don't think like this. Why?
I mean, there are historical examples of civil disobedience working to change fairly big things, right? Like, I mean, the ones that people always cite are like the suffragettes, right? Things like that, where civil disobedience has gotten us some very nice things. Do I personally think that it's like the perfect strategy? No, it's part of a much larger like movement with a diversity of tactics. But like at this stage, especially in the global north, I don't see an alternative to doing that. Whether or not like sort of a revolution can happen in the next 2 years, I think is a different question. And as I've said before, I don't think that's going to happen in the global north in the next 2 years. But I don't think that is the question we have to ask. The question is like, how can we force the structures that we have now, our governments, to like do the things that need to be done, right? How do we force Olaf Scholz to shut down the car industry? That is the problem we have to address. Because like, if we destroy the state, like then there isn't that capacity anymore, right? And so yeah, I don't know. Does that answer the question?
I don't know the author of the question. Okay.
So, I mean, like in short, no, emissions are still going up. However, like I think that seems orthogonal to like Greta Thunberg in particular, right? Like, I mean, sure. I mean, personally, I've never quite understood like the legal like strikes thing that the Fridays are doing. I think it's good to like show whatever presence on the streets every once in a while. But I think like the kinds of numbers you need for like legal demonstrations to like make the kind of changes that we need are astronomical. You need like the entire population in the streets. I think there is like sort of a sliding scale of like how many people you need and how illegal the actions you do are. And I think civil disobedience is somewhere in the middle, where like it's accessible to a lot of people, right? Like a street blockade is like whatever, a few €1,000 fine max, not like whatever, 20 years in prison. So you can get like a relatively large number of people to do it. And also like it's sort of like radical enough that like you don't need the entire population in the streets. But obviously, as I said, like diversity of tactics, you need everything. You need the people like doing just like legal stuff, and you need people, whatever, like going out in the middle of the night and sabotaging pipelines or whatever. But like, the point is, you need like at every level a certain number of people, and you need at every level more people. And I think the reason why I find civil disobedience so interesting is that it's a small step that for a lot of people is relatively feasible, right? Like, I mean, sitting down on the street and like getting carried away a few times, that is something almost anyone can do. And like for that kind of action to succeed in the next few years, to force the government to make at least, if not like something that completely turns things around, slows things down, is more feasible than a lot of the other strategies I've seen. And to me, like one of the few actually comprehensive strategies. You know, what exactly the future will bring is always unclear, but if we don't try, we're already fucked. So, you know, might as well like get a few fines now while while we still can.
Okay, thank you so much. Last question. If you could rewrite something in GNOME, what would you change?
Rewrite one component?
Yeah, rewrite something.
GNOME software. I would remove everything but Flatpak.
Okay, immediate answer. I think that we can like wrap up everything. Thank you so much, Tobias. It's been a really nice
Thank you.
talk.
Thanks for having me.
Thank you, everybody.
Okay. Final remark. 10:45. 2 minutes to close. Few points. First, Speck&Tech is run on donations. So if you help us, it's very appreciated. There's a desk down there. You see Nicola waving right now.
Hi, Nicola.
You can go there. You can get our T-shirt. You can get our swag. You can just donate for the beers and the Speck that you will enjoy in a few minutes. Second, stay tuned. Follow us on our social. third, right here in the kitchen, we got the Speck and the beers ready for you for the night. We need to kind of empty this room, so if you are having these kind of chairs, you can close them, you can stack them, and you can bring them at the entrance. This one's the green one. People having the black one, you can close them out again, and you can pile them here. People having these tiny, very colorful chairs, you can take them into the kitchen. But we're going to help you find the people wearing the Speck&Tech t-shirts, and they're going to tell you where to take them. The Speck and the beers will come. Thanks a lot, and see you at the Speck&Tech retreat.
Thank you so much.